Hello ma'am, this is Mukesh Kumar Yadav and I am going to talk about hill climbing algorithm. So, introduction of the hill climbing. Hill climbing is a heuristic search used for mathematical optimization problems in the field of artificial intelligence. Given a large set of inputs and a good heuristic function, it tries to find a sufficiently good solution to the problem. This solution may not be the global optimal maximum. In the above definition, mathematical optimization problem implies that hill climbing solves the problems where we need to maximize or minimize a given real function by choosing value from the given inputs. Example, traveling salesman, a problem where we need to minimize the distance traveled by the salesman. Heuristic search means that this search algorithm may not find the optimal solution to the problem. However, it will be given a good solution in a heuristic function. Heuristic function is a function that will rank all the possible alternatives at any branching step in a search algorithm based on the available information. It helps the algorithm to select the best route out of the possible route. So the features of the hill climbing. So those are all the features of hill climbing. It is a variant of generate the testing algorithm. The generate and test algorithm is as follow: generate possible solution, test to see if this is the expected solution. If the solution has been founded, quit, else go to the step 1. Hence, we call hill climbing as a variant of generate and test algorithm, as it takes the feedback from the test produced. Then this feedback is utilized by the generator is deciding is it in deciding the next move in search space. So use of the greedy search. At any point in space, the search moves in that direction only, which optimize the cost of the function with the hope of finding the optimal solution at the end. The type of the hill climbing. So that is the first type of hill climbing, simple hill climbing. It examines the neighboring nodes one by one and selects the first neighboring node, which optimize the current cost as next node. Step: evaluate the initial state. If it is a goal state, then stop and return success. Otherwise makes initial state as current state. Step 2: loop until the solution that state is found, or there are no new operators present which can be applied to the current state. Select a state that has not been yet applied to the current state and apply it to produce a new state. Perform this to evaluate new state. If the current state is a goal state, then stop the return success. If it is better than if it is better than the current state, then makes it current state and produce further. If it is not better than the current state, continue in the loop until a solution is found. Step it will be exist. If first examine all the neighboring nodes and then selects the node closest to the solution state of the next node. Step 1: evaluate the initial state. If it is the goal state, then stop the return success. Otherwise, make it initial state as current state. Step 2: to repeat this step until a solution is founded or current state does not change. Initial a new best state equal to current state and apply it to produce a new state perform this to evaluate new state and other than exist. It does not examine all the neighboring nodes before deciding which node to select. It just select a neighboring node at random and decides based on the amount of improvement in that neighbor whether to move to that neighbor or the examine another. Step 1, evaluate the initial state. If it is a goal state, then stop and return success, otherwise makes initial state as current state. And next step, repeat this step until a solution is founded or current state does not change. Select a state that has not been it applied to the current state. Applies successor function to the current state and generate all the neighbor state. Among the generate neighbor states which are the better than current state, choose a state choose a state randomly or based on some probability function. If the chosen state is a goal state, then return success else make it current state and repeat step and then exist. State space diagram for hill climbing. State space diagram is a graphical representation of the set of state our search algorithm can reach versus the value of our objective functions x-axis and y-axis. There are the two axes, x-axis and the y-axis. Denotes the denote the state denote the state space is states or configuration or our algorithm may reach, and y-axis denote the values of objective function corresponding to our particular state. The best solution will be that state space where objective function has maximum value. So that is the diagram of hill climbing algorithm. So different region in the state space algorithm space diagram. Local maximum, it is a state which is better than its neighboring state. However, there exist and state which is better than it. This state is better because here the value of the objective function is higher than it neighbors. Global maximum, it is the best possible state in the state space diagram. This because at this space objective function has highest value. And local maximum, it is a flat region of state space where neighboring state have the same value. Right, it is region which is higher than its neighbor but itself has a slope. It is a special kind of local maximum. Current state, the region of the state space diagram where we are currently present during the search. And soldier, it is a panel it is a panel that has a anvil edge. And the problem in different regions in hill climbing cannot reach the optimal best state. It enters the any of the following regions. Local maximum, at a local maximum all neighbor state have a values which is worse than the current state. Since hill climbing use a greedy approach, it will be not move to the rose state and terminate itself. The process will end even through a better solution may exist. The penalty and the rise. So thank you, man.